In this video, we've got this question. We are to evaluate the Laplace of 2 exponential minus t plus t raised to the power 4 minus t. Take note that minus t is the same as minus t raised to the power 1. Before now, we established standard Laplace transforms of different functions already, 7 of them you remember. It's very important for you to know these Laplace transforms at heart. Is that okay? So when problems are given to you, simply apply the one that solves the problem for you. Use the necessary principle and obtain your result. Come with me, let's work in this problem together. We are to evaluate the Laplace transform of 2 exponential minus t plus t raised to the power 4 minus t. You know, this is the same as the Laplace transform of 2 exponential minus t plus Laplace transform of t raised to the power 4 minus Laplace transform of t. Good. I've applied the plus minus rule. You know, there is sum and addition rule of Laplace transform. You know that these transform distribute over addition and subtraction. So I've split them as you see this. Okay, now looking at these functions, we have exponential functions, we have t raised to the power n function. It means I have to recall the standard Laplace transform for these functions. Let's recall that and see. Recall the Laplace transform of exponential minus at is equal to 1 over s plus a. This Laplace transform takes care of this. Is that okay? The Laplace transform of t raised to the power n is equal to n factorial all over s raised to the power n plus 1. This standard takes care of this and this. Is that okay? So we can now use it to obtain the Laplace transform of this function. It implies that the Laplace transform of 2 exponential minus t plus t raised to the power 4 minus t will now be equivalent or equal to Laplace transform of 2 exponential minus t. I will use this standard. Alright? This 2 is a constant, so it's meant to come out since it's multiplying this. Or if you feel like you can use the first shift theorem where exponential plus minus at is a multiplier of whatever function you have. But I would prefer to use that rule where if you have Laplace of a constant times a function, you bring out the constant, then take the Laplace of that function. So I'm bringing out these 2. So it's going to be 2 brackets the Laplace transform of exponential minus t. I will use this standard. Take note that a is minus 1 here. Is that also? Minus a here is minus 1. So it's going to be 1 all over s plus 1. Is that okay? So I fix that. 1 over s plus 1. I'm done with this. I'll come over to this plus t raised to the power 4. We apply this. T raised to the power n, which is n factorial. So n is 4 here. It's going to be 4 factorial all over s raised to the power 4 plus 1. Which of course will give us 5, we know that. Then again, we'll come to this and do same. Minus. This is t raised to the power 1. You apply this t raised to the power n factorial, which is the same as 1 factorial. Because n is 1 here. All over s raised to the power n plus 1, which is 1 plus 1. This is equal to 2 all over s plus 1. If you open up this bracket, coming over here, 4 factorial, you can evaluate it with your calculator. That is 4 times 3 times 2 times 1. You can stop at 2 because any term multiplied by 1 is that same thing. 4 times 3 is going to give us 12. 12 times 2 is 24. So this is 24 over s raised to the power 4 plus 1 is s raised to the power 5. Then minus 1 factorial is 1. 1 times 1. Is that okay? So it's going to be 1 over s raised to the power 1 plus 1, which is going to give us 2. And of course, we've obtained our results. This is the solution to this Laplace expression. Very simple, right? So all you need to do is to remember the standard Laplace transforms and your problems are solved. Question number 2. Evaluate Laplace of 3 cos 4t minus 4 exponential 2t plus 1 minus 6 sin t minus 4 sin 5t plus cos 5t. How do we obtain the Laplace of this function? Because it's a simple one. All you need to do is to identify all the functions you have there. Recall they are standard Laplace transforms. Okay, so we've got this, and to obtain the Laplace of 3 cos 4t minus 4 exponential 2t plus 1 minus 6 sin t minus 4 sin 5t plus cos 5t. Now, I have cos function there, sine function, exponential function, constant. I have sine and cos. Is that okay? So there is nothing wrong to recall their standard Laplace transforms. So before then we know that this is going to be equal to the Laplace. Let me write this as 3 times Laplace of cos 4t, then minus 4 times Laplace of exponential 2t, then plus Laplace of 1 minus 6 times Laplace of sine t, right? Then coming over here, minus 4 times Laplace of sine 5t, then lastly plus Laplace of cos 5t. Good. I'll now obtain the Laplace of each of them. Is that okay? I'll obtain the Laplace of each of them. You know that the Laplace of cos function, recall Laplace of cos at is equal to s all over s squared plus a squared. Good. That is for cos. Alright, the next is for the standard Laplace of exponential at is equal to 1 all over s minus a, 1 over s minus, because this is plus a, you know. Alright, the next one is standard Laplace transform of a constant. So Laplace transform of a constant, let me use a to be the constant, is equal to a over s. Then again, the next is for sine. Laplace transform of sine at, alright, is equal to a all over s squared plus a squared. I'm trying to recall the Laplace transform of each of them. It's not bad if in an exam situation we choose to write them out before we start using them, so that the examiner, you know, will look at it, okay, he or she is aware of the standard Laplace transforms of this function, so he knows what he's doing. She knows what he's doing. Is that okay? That's why I had to bring this out. Where are we now? We want to get the standard Laplace transform of sine. Laplace transform of sine at, we obtained it to be a all over s squared minus a squared. Remember, for hyperbolic functions, the denominator is minus. For a trig function, the denominator is positive. Then lastly, the Laplace transform of cos. Right, Laplace transform of cos at. Cos at is equal to s all over s squared minus a squared. Now, it implies that, going back to what I'm solving, Laplace transform of 3 cos 4t minus 4 exponential 2t plus 1 minus 6 sine t, then minus 4 sine, minus 4 sine, this is a hyperbolic function, sine 5t plus, right, okay, I think we've still got another term there, plus cos 5t is equal to, the first, remember, is equal to 3 times Laplace of cos 4t. And the standard of that of cos, we have the value as s over s squared plus a squared. Here, a is equal to 4. Is that not so? So this is going to be equal to 3 times s over s squared plus 4 squared, because a is 4. So it becomes 4 squared. Good. The next is minus 4 times the Laplace transform of exponential 2t. Look at the standard. So it's going to be 1 over s minus 2. You're going to multiply by this 4 there. So that's going to be times 1 over s minus 2. And then plus Laplace transform of this constant. Because we know the standard of Laplace transform of constant. And the constant there is 1. So it's going to be 1 over s. The next, minus 6 times Laplace transform of sine t. Take note, look at it. A here is 1 already, is that not so? And we know the standard Laplace transform of sine. Look at it. Is a all over s squared plus a squared. And our a here is what? 1. So it's going to be 1 all over s squared plus 1 squared. And 1 squared will still give you 1. Anyway, let me just indicate it. But it's not necessary. Move on again to the next. Minus 4 times Laplace transform of sine 5t. Sine, the standard Laplace transform is a over s squared minus a squared. Look at this. Our a is 5. You can say that. Our a is 5. So it's going to be 5 all over s squared minus 5 squared. Then lastly, that of cosh. Once again, we have that of cosh here, s over s squared minus a squared. Our a is what? 5 here. So it's going to be s all over s squared minus 5 squared. Good. This is what we've obtained. The next is to simplify. So this is going to be equal to, let's get a value and say, this term will give us 3s all over s squared plus 4 squared. 3s all over s squared plus 4 squared is 16. Then minus 4 times 1 will give us 4 all over s minus 2. Come in here, plus 1 over s. We come to this is minus 6. 6 times 1 is 6 all over s squared plus 1. Good, we are progressing. Then this is minus, please. I'm sorry, this term is plus, not minus, this last term. The last term is plus. Is that okay? The last term is plus. That plus cosh of 5t. Now, we are moving on to this term. This is minus 4 times 5 will give us 20. There is something I want us to take note of here, because I want to solve both of them at the same time. This is minus 4 times 5 is 20 plus 5. Alright? Is it plus 5 or plus s? Their denominators are the same. So don't you think that you need to work with LCM here? You need to work with what? LCM. And to do that, you have to combine these two terms. Since we have minus here, we'll factorize minus out. If you factorize minus out, this plus will also become minus. So what I'm going to do, this is minus, open brackets. Are you saying that right? They have common denominators, so I'm going to have s squared minus 25, because 5 squared is 25. Then this will become 4 times 5, which will give you 20. Add it to the numerator. Is it add to the numerator or subtract? Because this term will become minus, since we factorize minus out. This term bearing minus will become plus. And this term bearing plus will become minus. So this is going to give us 20 minus s. 20, 4 times 5, 20. Then this plus is minus, it becomes minus s. And this is our result. I don't have space to write answer. Let me fix up answer somewhere here. Good, so that's how we evaluate the Laplace transform of this function. In this video, we've got yet another question where we are to determine the Laplace of exponential minus 2t cosh 3t. Whenever you're given a problem like this, you see exponential multiplying any other function of t. You want to pause a little and think. Think about what? The rule of Laplace transform where exponential plus minus at is a multiplier. That is multiplication, right? Between this exponential function and this hyperbolic function. So we're going to take this hyperbolic function as our f of t. Let me write that out first. We have to evaluate Laplace of exponential minus 2t cos 3t. So we're going to say that f of t is equal to cos 3t. Is that okay? And then recall, we know that the Laplace of cos at is equal to s all over s squared minus a squared. Here, a is equal to 3. It implies that a is equal to 3 in this case. Is that okay? Now, this means that the Laplace of cos 3t will now be equal to s all over s squared minus 3 squared, which is s all over s squared minus 9. I will take the Laplace of cos 3t. There is a multiplier here. So since exponential minus 2t is a multiplier, use the first shift theorem. The first shift theorem. And what is the first shift theorem about? Okay? Let me use this blue marker. F of s will now be equal to f of s plus or minus a, as the case might be. But take note that in this case, exponential minus 2t, this is minus. So we're going to put f of s plus a into our solution. And take note that our solution is s all over s squared minus 9. Is that okay? It means that f of s will now become f of s plus a. What we want to do now is to replace s with s plus a. And what is our s plus a? S plus a will be s plus 3. Is that okay? Because a is 3. Take note, this is going to be plus because this exponential is to the power of minus 2. Alright, so this implies that the Laplace of exponential minus 2t cos 3t will now be equal to, we'll come to this solution. In place of s, I'm going to put s plus 3. In fact, let me indicate this, this is equal to f of s plus 3. Because a is 3 here. Is that okay? Now in place of this s, I'll kick it off and substitute s plus 3 all over. Come to this, kick off this s. Put s plus 3 there and raise it to power 2. Because the original s is raised to power 2. Is that okay? This is where we are anyway. And that will be minus 9. So this is the result of this Laplace transform. Take notes. Because exponential minus 2t is a multiplier, we use the first shift theorem where f of s, and what is our f of s? S all over s squared minus 9 will now become equal to f of s plus a, replacing this s with s plus a, and we know that a is what? 3. So go to this solution and fix s plus a, that is s plus 3 for all s.